Hello, everybody. Bon dia. I'm Jesus Espino. I'm a software engineer at Gitbot, and I'm going to talk about exploring a complex code base with AI. Let me introduce myself a bit and explain why I'm here and what is my motivation for giving this talk, actually. For the people that is from Spain, I used to work in Kaleidos. Some of you probably know that company. I used to work in Mattermost, that is an open source alternative to Slack. And now I'm working in Gitbot. That is a development environment in the cloud. It's an interesting project. Check it out. Also, I'm a public speaker. I do a lot of public speaking. I'm going to explain why I'm mentioning that here. And I'm an open source enthusiast. I really love open source. And that's the main reason why I want to give this talk. Because whenever, I've been using open source forever, and there's this thing that, open source is great because you can use it however you want, you can share it and all that stuff. And there is something that just always get me like, yeah, but no. It's like, no, and you have the source code, so you can explore that, you can investigate that, you can be sure that it's doing whatever they say they are doing. How many people here has investigated a source code that is not a library that I have in a problem with my code? Anybody here has explored that? Yeah. 3 hands, okay? Yeah, that's not like a pattern that is happening all over the industry. So almost nobody explored that kind of code bases because, to be fair, it's really, really hard to explore a code base that has been evolving for decades. So yeah, it's kind of fair to say, yeah, no, you are not going to get there and try to understand something like the Postgres database. There's also the fact that you probably know Python, Java, Go, whatever language that you use, and suddenly it's in another language. Maybe it's in Java, maybe it's in C, maybe it's in C++, and you don't feel comfortable with that language, so you are not going to go there and read Postgres or something like that. Well, that's a QR code with my social networks. I'm going to put the same QR code at the end anyway. And why I'm talking about this is because I've been like around 4 years exploring the Go source code, the Go code base, the compiler, the runtime, the standard library, getting into that code base, trying to understand how it works. I invested uncountable hours in that. So it has been a huge amount of effort. I enjoy that, so it's not like something that I regret doing, but the reality is has been a ton of time. I prepared around 6 talks, 6 different talks, all of them about Go internals. And now what I have is a huge sensation of wasted time. Because the reality is, all that uncountable hours that I invested in reading the Go source code with the things that I'm going to show you today, it's going to be like, oh, fuck, I will save hours and hours and hours and hours on each of them. So let's dive in. One of the things that I want to share first is I have 2 kind of modes to work with code bases. One is whenever I want to do something wide that is, it's not clear where in the code I'm trying to find out the information, or it's not really clear, or maybe the information that I want is spread all over the code. Something like, how is this code base structured? That's not one file. That's the whole repository. So if you entering a code base like the Go code base, what you are going to see is like, oh fuck, I have hundreds of thousands of lines of code to explore, and I don't even know where to start. So I don't know anything about this code base. So it's really hard to start getting into that. For that mode, for that vast code bases and wherever you don't know exactly what you are looking for, I normally use code agents. Something like Cloud Code or Codex or any of them. I'm specifically going to use ONA in this in this talk because it's the one that we have at Gitbot, and it's our project, but you can do that with any other code agent. So there's nothing special for this task in ONA. So it's just another code agent. You can use that in your, you can use, for example, Cloud Code. And the other kind of approach that I use is whenever I really know what is the files that I want to use or want to investigate, I use something that is called Either, that is kind of more similar to maybe Cursor or something like that, that is focused on, hey, I give you this file, that is the context that I'm going to give you, I'm going to give you some text, I'm going to send all that to the AI, and the AI is going to send me a response to that. It's one request, one response. No, it's not like the agents that is doing multiple requests, tooling, and things like that. The good side of that is that Either, or this kind of tools, is way more responsive. If you get an agent and say, hey, explore this code base, it's going to take minutes, and probably 10 minutes or 15 minutes in exploring the code base. If you do that with Either and you say, hey, I have this file, I want to ask you something, it's going to be seconds. And whenever you get the reply, you can ask more questions, you can do things like that. So what I'm going to do now is I'm going to copy and paste some of the agents, here. I'm going to take this here. This is Gitbot. I have already executed that just in case. So I'm going to select here. I'm going to paste here my text. This is the prompt for exploring the whole source code. And here's the prompt is, here is the full source code of Go programming language. Can you give me a high-level overview of how the Go compiler works, including all the steps in the compilation process? I'm going to take here the Go project, and I'm going to send this, and that is going to generate a new isolated environment that is going to spin that up, and it's going to do everything isolated there. So that's a good thing about ONA, because now I can go here, go back to my slides and continue this, but we are going to execute other agents, and they are going to be completely independent from each other. So they are not going to interfere with between them. The other thing that I like about, the other thing that I do with agents is, again, exploring big chunks of code can allow you to do things like, hey, what is the dependencies between things? That requires to explore the whole code base, and it can be really challenging. So I'm going to do that. I'm going to copy and paste that also here. I'm going to run another one. Analyze the dependency relationship between the packages in Go source code. Which modules depends on which others? Are they any cycles? Which packages are highly coupled? And generate a graph for that. Okay, go ahead. And the other use case that I want to share that is also very good with agents. Agents has the ability to execute MCP tools and things like that, but also have the ability to execute commands. And one of the commands that they can execute is Git. So they can use git log, for example. And they can use git show to see what happened in a commit and things like that, and git diff, all that stuff. So we can ask questions about the history of a project that I think is very, very cool too. Let me show something here. I'm going to call another one. I'm going to ask another one here. Look through the commits of in the last 3 months in the runtime directory, so the runtime of Go. What patterns do you notice? Which components of Go are evolving more actively, and what are are there lag refactoring or recurrent bug fixes? So it's basically check out the history for me and give me the insights of that. So I'm going to run this also. This is these agents are running, are doing their task, and are doing things, executing find command in this case, well, whatever. I'm going to leave this running, and at the end of the talk, I'm going to come back to this and see how it was. Okay, so let's come back to the presentation, and I'm going to go now and talk about something that I really like about using AI. Is I don't need to use AI in English, so I can feel. For example, whenever you read this Go source code, there's a lot of very good comments, but they are all in English. So I don't have any problem with that, but will be more comfortable for me to have everything documented in Spanish, and will be just simpler for me. So I'm going to show an example of that. In this case, I'm going to use either. Let me go to here and, okay, just one sec, here. I'm going to go to the SRC net HTTP, and I'm going to run either with Gemini. In this case, I'm going to use Gemini, and the rest of the talk, I'm going to use Anthropic. In this case, I'm using Gemini because I'm going to add a ton of code, so Anthropic wouldn't be able to digest that amount of code, but and I'm going to drop the test files. Drop. Okay, now I have all these files. It's going to read all these files, and it's going to send that files to Gemini, and it's going to give me an answer to my question. But in this case, my question is, ¿pots explicarme a qué es paquet net HTTP en català? I don't speak Catalonian, so I don't know what it means. There, I can guess it because it's kind of certain similarity with Spanish, but I'm asking, hey, explain me this in Catalonian. So I'm going to hit enter. That is going to take all this code and that request and send that to Gemini. Sometimes it doesn't reply in Catalonian, so let's see what it does this time. But anyway, whenever it replies, you can ask for, no, explain that to me in Catalonian, and it will do it. The other thing is, I don't know if this is correct because I did this with ChatGPT, so maybe that is crappy Catalonian, I don't know. And here is the explanation of the HTTP package in Catalonian. So it's pretty cool. Yeah, it's Catalonian, or sounds like Catalonian. I don't know if it's fully me, but yeah, that's one thing that I like. Whenever you need to know something about the code, it's normally easier to get that in your mother tongue. Let me show another thing. Another thing that I like is interrogating files. Interrogating files is exactly something that you want to do is, oh, I get this file here, and I don't know what it does exactly. So in this case, I'm going to change, I'm going to go to another directory. I'm going to go to the CMP compile, where is the compiler, internal syntax, and I'm going to run either with Anthropic Cloud, that is the default one. And in this case, I'm going to add the parser file and the notes file, and I'm going to paste this. I want to understand how the parser, the Go parser works and how the AST is represented. Can you explain me that? And it has the code files there, so it's going to read the files and explain to you what are how the parser works internally. So you are going to have a kind of clear vision of that. I'm going to prepare for asking another question, but yeah, that happens time to time. I can switch to Gemini if that's a problem. Okay. Okay, it's going to start explaining the parser architecture. I already know this because I investigated that myself, and it's very accurate. It's talking about the lexer, that is the previous step to the parser structure, and it's talking about the nodes, and all this is based on the code and is accurate. So it's not hallucinating, it's not making it up. But there's one thing here that is talking about position tracking. Position tracking, every node tracks its source position for error reporting, IDE features, and things like that. Okay, I want to know more about the position tracking. So, interesting. Can you explain me more details about the position tracking, how the position tracking works? So you can start having a conversation and getting into the details of the things that you found interesting, because sometimes it's like, oh, yeah, this. I'm going to give you this explanation that is very, very broad, or something like that, and you say, oh, but this point is the one that I'm interested, and you dig right in. So, yeah. The other thing that I like is one of the things whenever you are interrogating the AI about a code file or whatever, is the AI have a huge amount of knowledge about other things. It's not, I'm here giving the files to ground the replies to reality, but AI has a ton amount of knowledge about the whole industry. So, well, here is explaining all this, how how all that works, how the position tracking works. It's asking me certain things, but it doesn't matter. It's not important. But here's what you can do: is this design unique to Go? It is a common practice in programming languages, so you can ask questions that are more general, and it's going to come back to you with a very interesting reply. For example, if you see an algorithm there and say, okay, it's using the algorithm for whatever, and can you explain me what that algorithm, how that algorithm works in general? When was created? What were the authors? Is there any document that I can read about it? Things like that. You can ask questions that are general to the industry. And the AI gods are not with me today, so I have a lot of overloaded API problems. Anyway, in this case, it's giving me an answer like, hey, common practice across the languages. Yes, is something very common. You can see that in other languages, like C, C++, Java, Python, Rust, TypeScript, etc. Go distinctive features. What make Go different from other languages? The memory efficiency focus, incremental position-based updates, different things, and it's comparing me this implementation with other implementations in the industry. So this is, I think, very interesting for getting more into the details of the projects. It's basically getting yourself in the rabbit hole. So you start looking for something, but you end up getting into, you don't know exactly what, and it's pretty cool. The other thing that I do, and I think this is a very interesting one, I'm going to take a look to the garbage collector now. The garbage collector of Go is not an easy piece of software. It's complicated. So it's the Go garbage collector is in the file mgc.go in the runtime. So I'm going to add that file, mcg, and I'm going to ask a question about that. I can explain in details based on the source code how the garbage collector works. Okay, it's going to take the source code, read the source code, and explain me how the garbage collector works, and it's going to give me a lot of information. For example, in this case, it's going to tell me that the garbage collector of Go is a concurrent three-color mark and sweep garbage collector. What is kind of, if you know about garbage collector, that is, obviously, concurrent three-color mark and sweep. If you don't know about garbage collector, is what the hell is this? So you are going to get that information. It's very detailed, very very factual about what is in the code. It's explaining everything there. But if you try to read that and you don't have any background on garbage collectors, it's going to be challenging and it's going to be very dense. It's going to be hard to understand. So in those cases, what I do is ask the AI to explain that like I'm a junior. So that way, it's going to come back with a more digestible description of the garbage collector. What will be great to have something that you can really you can easily understand and easily read. The problem with that is now when it's taking time. I don't know. The problem with that is sometimes the junior explanation of a garbage collector is not easy enough. It's going to take you some time to understand it. It's going to take you some time to have a clear vision of how it works. So let's see if that. If not, okay, I'm going to go to Gemini. Sorry, I'm going to go back to Gemini. Model Gemini. I really like how Anthropic that does. I haven't tried this same pattern with Gemini, so let's see what it does. But I have to ask the explain and the detailed explanation first. So it should be faster because it's not retrying it's not retrying that much. I'm interested in getting first the raw description, the description that is more technical, because that way the Gemini is going to have that description and it's going to give you a better description later. So yeah, I kind of like more the Claude output, to be honest. Is more have more error, I will say. It's well, now I'm asking for the junior version of that, and it's going to try to explain that in a more accessible way. So it's going to talk about the same things, but it's going to be more detailed. Probably it's going to use some metaphors there. But the thing is, sometimes the junior version is not good enough for me. I'm 10 years old. This sounds silly, but if you ask for a 10 years old explanation, it's at least Claude. I don't know if Gemini is going to do the same, but Claude, it's going to come up with very good metaphors. It's going to explain, yeah, this is not the same. Well, in Claude Code, it's going to give you metaphors. It's going to, the last time that I tried this, in this specific code base was saying something like, oh, you have, imagine that you have a cleaning robot, and that cleaning robot has to clean the things, but you have stickers, and that stickers is the tricolor idea. So you put the stickers in things, and depending on what the sticker is in it, the cleaning robot is going to do whatever. So it's going to explain the concept with a very good metaphor. So what I will do is read the last version with the metaphors, with all these sugar on top of the real concepts. Then I'm going to read the junior one, and I'm going to have already a lot of mental model around the garbage collector that is simple to understand, that is simple to think about, and read the whole thing for the junior version. And whenever I understand the junior version, I'm going to go to the last one that is not going to be easy, but it's going to be way easier because most of the concepts are already in your head and already understood. And then if you want, you can go to the source code and start reading the source code. And the experience is completely different. I did it with getting into the source code and take me hours to figure out what was going on. So this way, you can have, in a matter of minutes, you can have a very good understanding of how the code is working. Probably you don't know the details, the specific details, but you can read the code file and orient understand where you are. So that's great. Other thing that I like is some people work are very visual when they are working. I'm going to try again with Claude. There's a lot of people that is very visual when they are learning, and they need to see schemas, diagrams, and things like that to understand the things better. Oh, it's easier for them. So one of the things that AI is that pretty good is generating images that are gorgeous and all that stuff. But generating schemas and diagrams that are accurate, that's not something that Sora or OpenAI does well. If you generate that, if you ask ChatGPT to generate a diagram of something, it's going to generate a nice diagram, but it's going to be like 3 blocks or 3 things, and no more than that, because it's not a space, it's not another space in the image and things like that. So it's completely useless. But what the AI does very well, it's coding. So what the solution for that, or the solution that I found, is instead of asking for an image, we ask for something that will generate the image. And that something can be something like Graphic, that is one of the things that I use, or Plant UML, or Mermaid. You just ask for something that is going to generate the diagram, but it's going to generate the diagram using code. So let me show an example of that. This took me a lot of time also. Runtime proc. This is where the Go routines that are lightweight processes, lightweight threads, works in Go. This file describes how they work. So what I'm going to do now is ask, can you explain me what are the different states that a Go routine can have, and what are the transitions from one to another? Use graphics to represent the different states and transitions. So if I run this, what it's going to do is going to read the file and try to figure out what are the states. It took me hours digging into the code, trying to understand everything. It took me a very good amount of hours exploring that to fully understand how the Go routines were transitioning from one state to another and things like that. So this thing will save me a ton of time for understanding that. And it's going to explain, these are the different states that are happening. And then it's going to say, and this is the graphic diagram for that. I'm going to copy and paste this quickly now. So, okay. Sorry. It's not letting me copy this properly. So, here. Yeah. Okay. Now I'm going to go here. No. Here. I'm going to move this here. And I have a version of this same thing, but this is what it has generated. This is the idle state, then it's dead, then runnable, running, syscall, waiting, and you can see that from running can go to waiting, from waiting can go to runnable, from running can go to syscall, from syscall can go to runnable, and also can go back to running from syscall directly. All this is really accurate, to be honest. This information, it's very accurate. It's saying actually when that happened. For example, it goes from waiting to runnable when you run go ready, or things like The syscalls is something that can happen whenever you are running something. There's fast syscall handling that goes back directly to running, or slow syscall handling that goes back to runnable whenever they finish, things like that. All this information, it's very accurate because it's based on the code, and give you a lot of insights. It will take me hours to reach this conclusion, and this way I will be, okay, now I understand this. I can go back to the code and be sure that everything makes sense in my head. So yeah, for the people that is more into learning that way, it's pretty cool. The other thing that I like a lot is whenever I read something, it takes me time to be sure that I understand the things. So yeah, I read the thing. Okay, you give me an explanation. Let me start with that. I'm going to go here and I'm going to get out of here and run it again and add the. I'm going to add the channel implementation from Go. That is a communication mechanism for Go routines for the light processes. So that's represented here. So with that, I have all the information about channels. So I'm going to go here and say, give me a detailed explanation about how channels work internally in Golang. Use the source code as source of truth. That is going to give me the explanation. But what I want here is not the explanation. I want the explanation. I'm going to read the explanation, understand everything in the explanation. This is the demo effect. This hasn't happened to me this morning. I was trying things this morning and it wasn't happening. So I'm really sorry about that. Yeah, now. This is giving me a very detailed explanation about how the channels works under the hood, the structure that is using, things like the buffering, indexes. All this is very accurate. Again, I know this part of the code, and it's really accurate what it's saying here, at least at first sight. But the important thing, or the thing that I want to show now is whenever you finish reading all that, whenever you finish understanding how channels works, you can go here and say, now I want to know how much I understand the topic, so I want you to ask me questions. I'll answer the questions and you tell me if it's right or wrong and why. Then we can pass to the next question. The question has to be in 4-option text format, and make the questions from very easy to very hard, incrementing the difficulty gradually. The idea of this, well, you can do, give me 4 options test, or just ask me questions and I'm going to answer in test format. I can just write the answer and it's going to say, oh, well, this is partially right or partially wrong, or it's completely right or whatever. But I use the 4 options format because it's very easy to demo that. So let's see if Claude wants to give me an answer, or in this case, a question. Okay, here. Question 1, easy. What is the main data structure, blah, blah, blah. The main data structure of the channels is, the answer is B in this case, that is HChan. And it's going to say, oh, this is correct, that is why it's correct, and all that stuff. It's going to give me some, a very good answer about that. Okay. I'm really sorry about the speed of Anthropic. I don't know. I guess it's bad timing, and the talk is, well, here is giving me, the answer is correct, and this is the right answer, why this is correct, blah, blah, blah. The other question is, when you create a buffer channel, blah, 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 it's going to, what represents this number 5 in the struct? The right answer for this is the is the B, data queue size. So I'm going to use the C that is wrong, and to see an example of that being wrong. Yeah, that's incorrect. This is why it's incorrect, and this is the answer. This is why the correct answer is the whatever. So the why B is correct. The correct is B, and that's the reason. Okay, this is another thing that I love. Then I think I don't have any other things, but if you start using this for learning about code bases, you are going to start seeing patterns that work for you and things like that. Now I'm going to go back to Ona and see the responses that Ona gave me. So I have this first one that was the Go compiler architecture, and I'm going to see here that it's again, I investigated this specific topic. I've done talks about it, so I know fairly well the process of the compiler. And this is very accurate. The parsing phase that has the lexical analysis, the syntax analysis, the AST building, then is the type checking phase that's correct. Then it's constructed the intermediate representation that is walked. And there's also some optimizations that are explained here, the virtualization, escape analysis, things like that. All this is correct. Then you have the SSA generation that is, well, and some optimizations around the SSA generation, machine code generation, and exports data generation. So all this is pretty accurate, and is pretty cool that you can have a very good overview of how the compiler works in just minutes. The dependency analysis was the other thing that we asked for. So the dependency analysis is it's very interesting how it solved that. In this case, here, what it's doing, actually, this is the history, but if you see this, it's going to use some scripts. It's building some scripts to do the exploration of dependencies. So it's building that, and well, the analysis results, key statistics, this package, this number of package analyzers, 13 dependency cycles detected, the most dependent packages, critical cycles. It's generated some files. We can check it out here, actually. I can go here and say, yeah, let me see this generated file here, for example, the core dependency dot. So it's generating me a graph-bit file with the core dependencies between things. And there's another with all the dependencies. So it's generating things for representing that in graph-bit. And the dependency analysis has a lot of information here also. So, well, let me go back to this. And then we have the history. This is another interesting one, because this way I can say, okay, there's my development patterns is the sync test bubble infrastructure that have 15 commits related to that. It's explaining what it's doing there. Checking finalizer debugging system that has another 10 commits, memory management. And so with this, I can have a clear understanding of where the development is happening, or where what are the active parts of development in the Go compiler. In this case, in the Go runtime, actually. So it's an interesting thing for any project. Imagine that I want to explore Postgres, and I want to say, oh, what are the indexes that are evolving? How often they change? Is something that they change a lot, or is something that, no, the indexes hasn't changed in the last year almost? So it depends on you can get a lot of cool insights from that. And with this, I think we are done. So, yep. Thanks for exploring with us, with the AI and me. I want to encourage you, everybody, to just try it. I want to show something here. The questions thing, I get the information about how the channel works and start asking me questions and all that stuff, it took me 20 cents. So it's not super expensive. My expectation is, in most cases, your company is going to pay for this kind of subscription of this kind of API keys. So it's not expensive, and it's going to save you hours and hours of time understanding these source codes. So I want to encourage you, all of you, of trying this, exploring codebase, the tools that you use, if it's Git, or if it's the database, if it's your language compiler or interpreter. Just check it out and take a look and try to understand how the foundational software that you use every day works. And yeah, with this, let's keep in touch. There's the feedback for the talk in the webpage of the DevBcn. And if you want to contact me, and if you want to talk about AI, Go, or whatever, I'm happy to talk. So that's it. We have some time for questions also. Yep.
Hello. Yeah. Thank you for the presentation. It was very nice, very interesting. But I was wondering, in the situation where you want to analyze your company's code base and for whatever reason you're not yet allowed to use a remote AI agent, is a locally hosted AI agent a decent solution for this? Do you have any experience with that?
I haven't tried that because my gut feeling says that it's not going to be up to the level of Anthropic. My experience, Anthropic is outstanding for code generation and code understanding, but probably it's going to be something like Queen Coder or DeepSeek Coder. Probably is going to be way better than nothing. So that's my expectation. That's also in that regard. I just recently joined Gitpod, and one of the things that I've done is exploring the Gitpod source code using AI, because Gitpod allows me to do that with the company. Keys and the company, and the company agent. So I was using that to explore the code base. So it's something that makes a lot of sense, not only for open source projects, for if you change a company or you change the project in your company and suddenly you are assigned to a project that have 500,000 lines of code. If you want to understand that relatively quickly, this is a great approach. But yeah, open source models are not as good, but probably way better than nothing. And the good thing about this is it's grounded on the source code, so it's not going to hallucinate that much because it's grounded on the source code. So the source code is there, so it can misinterpreted the source code, but at the end of the day, it's based on that data. It's not like, give me an answer about the Go compiler. If I push enough ChatGPT to give me answers about the Go compiler that are wrong, it's going to give me wrong answers. It's going to be easier for smaller models, but yeah. And when I say smaller models, I'm thinking about something like 30 billion parameters models, not like 2 billion parameters models. 2 billion parameter models is going to screw that almost for sure, because it's too small. But something that you can run in maybe a Mac with unified memory, that something like a 30 billion parameter model, that I think that will be way better than nothing. Sorry. Any other question?
Any more questions?
So you spent a few bucks while doing this demo. How do you feel about that? Are you paying from your personal budget to play with all that?
Sorry, can you repeat that?
I think you spent quite a few dollars while doing this demo, while preparing it. How do you feel about that?
I feel really good about that, to be honest. I don't feel bad. I don't feel guilty about that spend. I think it's very well spent money. Probably between the preparation of this talk and the talk itself, I have spent maybe $50 or maybe $70. That is my company is going to pay for that. That's not a huge deal for me. But the reality is, $50 is nothing compared to what I spend every single day using AI, using agents. So I can spend more than $50 per day using agents in my company for doing my work, and it's still very, very, very cheap. Think about how much time it's 1 hour of your time. 1 hour of your time is expensive. If you save 3 hours and you have to spend a whole set of 20 cents or 50 cents, the numbers are going to be very easy to justify. I'm saying I will save hours and hours and hours of work to understand every single thing that we have seen here, hours and hours of work. And $50 for that is more or less a thick book. So it will worth it 100%. For me, maybe other people have other preference. Also, Anthropic, for example, now has fixed subscriptions, something like, you have $20, you pay $20 and you have a lot of usage of the API. So with that, probably it's going to be very reasonable to do something like this, and you are not going to hit the limits that often. Any other questions? Okay, thank you everybody for coming.
Thank you.